Want to know the easiest way to make cash? Become a Dasher with DoorDash and make cash whenever you want. All you have to do is download the DoorDash Dasher app. Signing up only takes a few minutes. You can dash with a car, a scooter, even a bike. Once you're in, you can start earning whenever you want. No boss and no schedule. The best part is you can cash out instantly. No more waiting for payday. Visit DoorDash.com/earn today to learn more.
We're live. Hey. All right, we are back. This is, I believe, stream 8 for the Dwarf Fortress mono game clone. I do have an agenda for this one, and I think it's just something that we have to address no matter what at some point. So one of the biggest gripes that I currently have is, let's say, we have our globals here. We have these constants. Okay, so we know Dwarf 1, it's at column 0, column 1, row 0. We open up the resources here. We look at the sprite sheet. Okay, we do that, right? And that's kind of painful, right? We just have to know which ones these are. So what we're going to do is build just a really quick and dirty Windows Forms. I know, disgusting, Windows Forms. But it's just a really basic tool that's going to allow us to point and click, and it's going to tell us what those rows and columns are. There'll be two parts to it. The first one will be about just, which we'll put in place today, will just simply be, you click on it and it tells you where it's at. It is going to build upon another portion where we're going to give these names, and then we can export this data and then load it in real time. So this way, if we want to change the name of something, it's going to be a lot easier. It'll be pretty straightforward, I think. It might be a little long because building tools, takes a while. It's not the most fun thing to do, but yeah, let's go ahead and get started. All right. So let's take a look at where we're at currently. The music's not too loud, is it? Okay. So yep, you walk around, pick this stuff up, and it says hello Twitch. All right. So what we're going to do first is we need a way to share some of this data, and I believe this is in .NET 6. Did I put it on 6? Yes, we're in .NET 6. That's compatible with Standard 2.0, and the WinForms is not going to be in .NET Core. There is an issue that I'm running into that I was not able to figure out. I have it on my old project. I wasn't able to figure it out either, where I couldn't use .NET Framework and the MonoGame Forms library. So we'll just make it in .NET Framework. 4.8 should be fine. Let's do that first here. So desktop, Windows Form app, .NET Framework. Let's see. Let's call it monogame df clone tool. Sure. And we'll put it in 4.8. I probably can't do 4.8.1. I need to install it. And here's the thing. If you do not have this option here, you don't have 4.8, you could really pick probably anywhere from 4.7 on up. And let's say you have none of those. I will show you how to get those. So let's go ahead and first add this. We'll create the project. So now if you did not have the 4.8 option or anything like 4.72 or any of that, you simply go up here to Tools and do Get Tools and Features. Now, my version of Visual Studio is bugged. See this how I no matter what I do, it just retries. So I have to install this crap manually usually. However, yours should work. There's a button, there's a tab here that has a bundle of stuff, like for instance, a bundle for desktop forms, a bundle for C++, all that kind of stuff. There's a section up here called Individual Components. Click that and look into the .NET section, and you should find 4.8.1 or 4.8 or 4.7.2, whichever one. Install the SDK and the runtime framework, and then you should be good to go. So the tool that I'm using, or not tool, but the library that we'll be using here is called monogame.forms, I believe. Games.form.dx. Yes, because I had a problem with the OpenGL. Now, technically, this one is using OpenGL, but these two are not going to share any rendering context of any sort, so it really doesn't matter. There just seemed to be a bug that I could not get around it. Excuse me. And we're going to downgrade to 2.4.9, I believe. I think that's... I had some issues with 3.0 as well, so unfortunately this stuff isn't the latest and greatest. I just couldn't get it figured out. I don't think it's, again, it's just a tool. None of that really matters what we're using. So let's go ahead and install, I believe, 2.4. Oh, should be fine. We agree. And then we need to add something that's going to be able to share the data between these two. We're not going to quite do it. We're not going to be doing it quite yet, but it's going to be at some point we're going to have to. So .NET Framework 4.8 and .NET 6 are compatible with .NET Standard 2.0. There's a website that you can use out there. If you just were to go and use your search engine and search for it, you'll find a graph where it just contains which version is it and what it's compatible with. So in here, we'll just switch this to library. And we want it to be class library. Make sure you're not picking a .NET Framework one. So I don't know, one of these down here. Yeah, don't pick this one. Pick this one here that targets .NET Standard or .NET Core. Click Next here. Call it monogame df clone.shared. At the moment, it's only going to share one class, but they will eventually share more. Yep, .NET Standard 2.0. And the information that we need these two to share, simply for now, is just going to be a sprite sheet tile. So let's pull up this image and I'll show you what I mean. So in here, this would be a sprite sheet, and these individual tiles here are the sprite sheet tiles. So it's really kind of a lot like the game cell that we have currently, but its only purpose is to serve like at this position, you know, at column 1, row 0, dwarf 1 exists. Now, like I said, we can hard code it, we can put it in here and do it like that, but it's that you can see how that would get painful over time. So what we're trying to solve here is you'll be able to pull this up and just click it, and it'll tell you what it is. And then eventually what it will do is it'll either spit out a JSON file that we can read and serialize during the time that we load the game up. Or what I thought would be kind of neat is to have different options. We could leave these be technically hard-coded like this, right? What it could do is spit out the text string of this here. So this way you could just copy it and just paste it right in. I haven't really decided which route we're going to go, but I think that should be fine for now. Let me check. I want to make sure. I need to do a volume check. I want to first make sure that the audio is going and nothing's too loud in the background, because I've noticed I've kind of screwed that up in past videos, so give me one moment. I think that's good. We'll leave it like that for now. Okay, so now we need the data here. So let's start by renaming this one. We'll call it sprite sheet tile. Sprite sheet tile. That should be fine. Yep, we'll rename it. And this is going to have some very basic information. There won't be anything too fancy. We have public, keep it in the shared namespace. We're going to add a column for public int column, get set, public int row. Then we're going to have it named, because it'd be nice to give these a specific name, right? We're not going to make use of the name quite yet, not in this one, but in future when we expand on this tool, we will be. So we'll give it public string. It'll just be name, and then there might be some just really basic metadata that we can just pass in. So I think it'd be good to have something like, say, a public list string, and we'll just have metadata. And let's go ahead and just new that up as well. Bring in. So this way when we reference it and try to add something to it, we don't get it blown up, because we know it's going to have something or it'll just be empty. So then within the here, let's just give it a name. For now, we're not going to have like say a menu and then open them up as dialogues or anything like that. We're just going to have it be just this. We might expand it, because there might be instances where we want to create something like a prefab, or well, not really a prefab in the same sense that you would think of a normal game engine, but just something that's a series of a collection of tiles. Maybe something like animations, for example. Even though in Dwarf Fortress things don't technically animate, I think it'd be okay just to add it anyway, because it's just good stuff to know, right? You know, especially if you're new to this. I mean, if you're not new to this, I don't know why you're watching, because man, you probably hate everything about this, because yeah, I'm not game programming isn't my specific thing. But I do really enjoy it as a hobby, and kind of the point of this whole channel is I noticed that, like, wow, I have like a really obscure idea of something I want to do. I wonder if there's a YouTube video on it, and usually there's not. So I'm trying to cover things that you normally wouldn't be able to find a video on. It's kind of niche, right? You know, it's just mostly for fun. Anyway, enough of that. We'll call this the sprite sheet editor. I think, yeah. These names, you know, might change over time, but for now this is fine. Okay, so let's give this sprite sheet editor. Okay. So now what we need to do is we need to create basically a window to render this on. So what I typically like to do in my tools is I create a new folder. I'm going to call it MG Controls. And we'll add a sprite sheet renderer class. Sprite sheet renderer. Okay. And the sprite sheet renderer technically will inherit from a class that comes with the I can't think. That comes with the library, and that is called the monogame control. And then that will allow us to then use this as a context. And this one technically is a DirectX context. Our other one is OpenGL context, but anyway. This will allow us to kind of work similar with how Monogame does, and this one even comes with a built-in camera, so I think that's kind of nice. I kind of wish Monogame came with like just a little basic built-in camera just for like prototyping purposes. So let's inherit from, maybe I should zoom in. I hope this hasn't been too small for you all, but yeah, here we go. Okay, so Monogame control. Yes, there we go. And then we gotta override some of these methods. So let's take a look at what we have for overrides. So we definitely need initialize. We need update. And draw. We'll start with that. Oh, it doesn't keep them? Huh. Ah, bummer. Try that again. Initialize. And then when I back this out and then do draw, and then when I back this out, does initialize not stay checked? Yeah, I don't know what happened last time. So do update, and that should be good. There we go. That's what I'm looking for. And my OCD drives me nuts. This has to go down at the bottom. Drawing has to be at the very last. Initialize has to be at the top, and update somewhere in the middle. Or I will, my OCD will just go nuts. Okay, so we need some properties here. For instance, we know that these there's tile size is 16, so we can do a public const int tile size, and this is technically stored in our globals, but I don't want to pull our globals out in case we want to store some monogame specific items, and then there could be a clash between the types that are used in monogame forms and that. Anything that's in the shared is going to mostly just be other classes, or what are they called? Primitives, yeah, because we just need some way to share it where neither really cares what it is. It's just some data structures. So let's give this 16. We need we need our texture too. So we'll do that. We need public texture 2D. Texture. We need another texture, and we're gonna have to build a texture from scratch just for our boxes. And there are just call it selector. Let me focus here. Selector. Okay. Then we need the content manager, and I'll backtrack to my point there here in a moment once we get some of this boilerplate stuff out of the way. Content. That should be good for now. So let's take a look at the draw method in here. So the way that the draw works is we can call, the way that we get to the sprite batch is, you'll notice there is no sprite batch being passed in. And that's just because it's part of the editor class. So I don't think we need the base implementation for draw, so it would become graphics device dot clear, and the color dot black. And we'll do editor dot begin camera 2D. I like it. So we do sprite mode, dot immediate is fine. Blend state dot alpha. Sampler state dot point plant. Null. Okay. And then we need to draw this texture. But first let's end the camera. So editor.cam or end camera 2D. End camera 2D. So we need to draw it. Obviously we need to load it too, but let's take a look. Just I want to show you kind of how similar it is to just MonoGame's regular code. So it has a sprite batch class dot draw, and you just do texture. It's just going to be drawn at vector 2.0, no rectangle, and color dot white. So now we need to load this texture up, and the way that we do that is we need to get the content manager going. So I think we can just do that right here in the initialize method. So we'll do content goes new content manager, and then we simply pass in the service provider, which MonoGame controller comes with a services, an implementation of services that the service container here. So thankfully we have access to that. We don't have to figure that out. So, and then this is the root directory. We will keep it the exact same as, say, this project up here, because we named it resources. So now what we need to do also is let's add a folder, and we'll call it resources. And honestly, since this texture is not going to change, just grab it from here. So what was it? It's spritesheet.xmd. Just grab it, drop it right in here. Make sure the copy local is set to true, or always rather. Hit save all. Close out all this. So now we should be able to say something like underscore texture dot or equals underscore content dot load texture 2D, and then we'll pass in sprite sheet. So now it should load the sprite sheet, and it should draw it. Now the thing is, how do we get it onto here? And this is what's really cool about it, is you just first need to do a build, because if you haven't done a build yet, it's not going to show up in the list. But there is a custom controller. See right over here on the left, it created this sprite sheet renderer. Just drag this bad boy right on here. Set it right here for now. Let's give it a good name. I just take out the 1, really. I think that's sufficient. Save all. Let's set the monogame.df clone to the startup project. And let's run it. And let's see what it looks like. Or if we get errors, one of the two. And there we go. Pretty simple. It works pretty much exactly like MonoGame. So now what we need is a way to kind of move the camera around and everything like that, because you know most tools, they would come with a way to drag, drop. We're going to use the mouse, the middle mouse. If you want, you can make it left, the right click and drag and drop. I've heard multiple UX experience gurus, or whatever you want to call them, not gurus, but experts that all say that it should be left click, and some say no, it should be the middle mouse. I don't care. You can pick whichever one you want. It matters. Does not matter to me. So in order to do that, we need to know what we're not going to build like an input manager for the mouse, but we'll just kind of put a decent one here. Just something that we can just tell if it was a click, because inside the update method that's being called multiple times, it's, you don't want to be like when it's pressed, because it's pressed for multiple frames, and you don't want to be released because it's technically released in multiple frames. So we need to just store what the previous mouse state is. So for the mouse state, input for just that one uses MonoGame. So we'll do previous mouse state, and then within our update method, first thing we want to do is make sure that the mouse is in the control, and there's a method for that. So is mouse inside control. So we get the mouse state will be so this will be the current state. So m state equals mouse dot get state, and then if m state dot left button equals So button state dot pressed and m state dot left button equals buttons. Oh wait, no, we want to look at the previous state. So and previous state equals dot left button. Jeez, dot left button equals button state dot released. This should be enough to just fire the click event once here. So that should be good. This will be just for selecting. Let's just make sure nothing blows up in it here. Okay, that's good. We should have an event that raises here. Let's do that. Let's create an event, and that works no different than if you've ever made controls for WinForms in the past. I've never done it professionally, but I've done it for the fun of it, and it's pretty simple. So within here, we need to create an event. So that would just become public event handler. Yep, it's part of system namespace, and we'll just do on select. Sure. So then within here, once we know it's been clicked, this is just confirming that the mouse is inside the control and something was clicked. We can then just raise an event and subscribe to it on the parent. So let's do event handler on select. Then we want to make sure, do a ternary, or not ternary, but yeah, is this ternary where we're checking for null before? Anyway, dot invoke, and the sender will end up being the sprite sheet tile, but we'll get to that in a moment. We'll just pass in null, and then just new event arg, or we can actually just do event args dot empty. Yeah. Okay, so now let's go on here and subscribe to that event. Speaking of, if you're watching from YouTube, don't forget to subscribe. God, that was awful. Okay, so now you should see if, let's see, it might not be here. Maybe I need to do a build here real quick. Now let's see if we get the select method. Why are we not getting it? I made it public, right? Yeah, public event on select. Oh, on select. Okay, yeah. LMNO on select. Why am I not getting it? So we're in the sprite sheet renderer. Let me get out my rubber duck for rubber duck debugging. This guy right here. Pretty cool. Got him for like $1. Alright, so we have a public event on select. That should be just enough for this to be able to subscribe to it, though. Maybe I need to run it once and it's just caching it. It's not picking up. So now let's see if it's... I'm going to try changing or just closing this out and reopening it, maybe. So in events, LMN, there it is. I don't know what the deal was there. Anyway, so now we have the onSelect method. So now we should be able to do something. Let's just make something happen. We're going to need a list box here. So let's add that in. Add a list box. There we go. Yeah. This could get pretty large because we're going to generate them right off the bat. And then we'll name this LST box sprite sheet tiles. Sure. So maybe inside here, just to test to make sure it's working, we just do LST dot items dot add. I don't know if that quite works, but let's see. Okay, yeah, that works. So it is firing multiple times, which is not what we want. So that means our method in the sprite sheet render is not quite working. It's firing it multiple times. Ah, duh. Okay, I forgot to set the previous state. So let's rename that. I'll just go previous mouse state. So then we have our previous mouse state just needs to be set to the M state. So now when we click it, it should just add 1. Yep, every time we click, it just adds 1. All right, so we got that working. Now let's get that camera going here. So we're actually going to override some methods here. So when the mouse is down, we need to be able to tell it when it was first, like where it was at and where it's being dragged to. So let's add some variables at the top here that will allow us to do that. So we have our, let's see, cam mouse down is probably a good one. So private bool cam mouse down. And we can initialize that to false. Then we need a point, actually, if I remember correctly, because that it works off of points, and then we can just convert it to a vector in the end. So we have a private point, underscore cam drag position. And then now we will override the method for when the mouse is down. So there is a protected override void on mouse down. And to make things a little bit easier, let's do this. Alright, so this way we can shrink this up a little bit. And then we get the mouse event args, and then within there we can check if e.button equals mouse buttons, right? Yeah. Dot middle. Mouse buttons dot middle. Could have sworn I just saw mouse buttons there. Hang on. So mouse buttons. Yeah. So this is a thing. Dot. Is there a clash in this, I wonder? It's very possible. Yeah, so mouse buttons need to be... I think I get it. Yeah, so if we look at this, this is going inside monogame's control? Maybe? I hope, if I'm reading this right. Wow, it's a huge object. No, it's windows.system forms. You know, let's add a... using statement here again. Mouse buttons equals system.windows.forms.mouse buttons. Okay, so now there shouldn't be any clash, and we get the right one. Dot is down. Dot. Thinking here. So mouse button is dot middle. Just middle. There. Okay, now we're getting it right. All right. So if e dot button equals mouse buttons dot middle, we're gonna say that the cam mouse is down. Which is true. And the cam drag position will be equal to new point e dot x. E dot x, e dot y. So now this should set these variables accordingly. We need to also override the mouse up as well. So protected override void on mouse up. And then basically all we're doing here is just saying that the cam mouse down is set to false. Yep, because the mouse is down, we're checking if the middle, and then we'd be dragging it from there. Okay. So then we need to also... what else here? So we have mouse down. Yeah, we need the mouse move, so we're going to override on that. So protected, override, void, mouse move. Yes. Okay. Within the mouse move, the only thing that we need to do for sure is we need to check if it's down first. So that's the only time that we're going to ever do anything. So we need to calculate the difference between where the cam mouse was held down and where it's currently being I don't know. English, I'm not good at English. So we need to figure out the difference. So int x diff equal to cam drag position, which we're setting up here, dot x minus e dot location dot x. And then we have int y diff equals cam drag position dot y minus, what I meant to do, minus, and then cam position y minus e dot location dot y. So then there's a method to move the camera, so editor dot move cam. And then in here is where we're going to specify the vector 2 that we're making out of the difference here. So new vector 2, x diff and y diff. And then we set, the cam drag position dot x equal to e dot location dot x, cam drag position dot I think that's right. In the event, now the camera should at least move. Now whether it's going to move the way we expect. Oh, okay, so that actually did work. Yeah, so I'm holding the mouse button down and I'm dragging it and moving it around. Okay. Yep, that is correct then. So then now there are no overrides for this. So we're actually going to subscribe to events for the zoom, because I wasn't able to find anything about like zooming in with monogame forms portion here. It's not impossible, it exists and I'm just missing it. But in any event, we need to subscribe to when this gets moved up and when this gets moved down. So let's do first one to be, let's make the first one up. So we'll do protected void, so sprite sheet render on mouse wheel up, mouse event args e, and editor dot cam dot zoom plus equals, let's store a variable because we're going to have an amount that we zoom in and out by. I think we'll test with these and see what feels natural. Probably float underscore cam mouse zoom speed 0.03. Let's make it 0.3 for now. And then we need the same thing, but in reverse. Go. This one's minus equals. And then now in our initialize method, we have to subscribe to these events, otherwise it wouldn't know. So within here, we will just do on mouse, sprite renderer underscore on mouse wheel down plus equals. No, I have it the other way around. It would be on mouse wheel downwards plus equals. So yes, and then we gotta do the same for up. On mouse wheel upwards, and we change this to up. So now when we go like this, when we launch it, it should zoom in and out. Well, let's see. There we go. Zooming in, zooming out, zooming in, zooming out. Cool. So now that we have that in place, we need to be able to select these guys and then have it, actually display over here. This one is at column 0, row 1, or anything like that, or column 6, row 9, etc. Now, since we're changing the transform, it's not quite as simple as just taking, say, the X and Y position of the mouse, dividing it, and getting math.ceiling. You still have to do that, but the mouse position is, you have to look at the relative mouse position, because the mouse position will show that while it's zoomed out right here, it's perfect. You can click here and that would work, but the moment you move the camera and do some zooming, you're going to get it where you select here, and then it's going to select something down here. It's just going to throw it off. So we have to accommodate for that. And that's actually pretty simple. So within the update method, we will do that. First, let's Do we want to do that right now? Actually, we need a selector, and this is where we need to create a texture on the fly. This right? Well, let's get to the texture. So, the way that you do it, I don't know if there's a better way to do it, but this is how I've done it in the past. Is you do, I'm just going to say selector equals new texture 2D, pass in the graphics device. And then the width is just 1 pixel by 1 pixel. That's all we're going to do there. And then we need to, we're going to make it red, so selector.set data. It's going to be a new color array, color.red. And then within our draw method, we're going to create a method that will allow us to basically just draw a rectangle from it. And then we do that by building up multiple rectangles. So this part's a little tedious, but it all works out in the end. So we'll do private void draw selector rectangle rect. We need a size of the frame, which is just 1 pixel. So we want const int t just equal to 1. That's fine. So rectangle rect1 be equal to new rectangle. It'll be the rectangle that we're passing in here, which is going to make up our x and y position, mind you. So we're going to have new rectangle dot x rect y. The width just be 1, so it's the width t, and then rect dot height. Okay, so that should be x, y, and the height, and then the height. So that should be going that direction. Now we need, let's make a copy of this for a rect2, which will be y plus the rect height. Rect height. No, minus, right? No, it'd be plus. And then minus t. Minus t. And then within here, x, y, t minus y. I cannot write a lowercase t for the life of me. So then this would become rect.width. Width. And then this next one would just be the value of t. Height. So that's our opposite side, I believe. So we have rectangle. Oh man, rectangle. Rect 3. New rectangle. And then this one, the x never technically changes. I mean, it changes based on what we're passing in. So these technically, yeah, so let's do rect.x plus dot width minus t. Yep, because this one would be y, this one's going to be the x, so we need to take it minus t. Rect dot y, then the width of t, and then rect dot height. Rect dot height. Okay. I'll make sure I have that right. So we have x plus the width minus t. Just the given y, the pixel here, and then the height, and then we need a fourth rectangle. Rect 4 equal to new rectangle. So we have rect dot x, rect dot y, and then we need the width dot width, and then t becomes our height value. Yeah, because it's 1 pixel in width. So now we'll do color red, color color.red. And then we're going to draw each individual rectangle, which should create that 1 pixel's worth, if that's done right. So we do, yeah, let's do editor, sprite batch.draw, selector, rect 1, and color. And then we draw all 4 of them. So let's see if it just draws it without really specifying. We'll just do rectangle 0, 0, 16, 16, just for now. And then our rectangle here, these will become our X and Y. So it should show up on the top left corner. I wouldn't be shocked if I made a mistake here. No, actually I didn't. Okay. So now it's drawing this rectangle up here. That's good. So now we want it to be where you click it and it's going to actually select that rectangle. So to do that, it's pretty simple. Within our update method, we need to do it here. So first let's create the actual data that this is going to use up. So let's create a dictionary up here. So we'll have a public my dictionary string sprite sheet tile. Let's bring that in. Yeah, we have to add a reference to shared here. I didn't do that apparently. Underscore sprite sheet tiles. Dictionary. Do I want systems.collection.generics? Yeah, probably. And I can just literally copy this over. Then we're not gonna want to define these within here. I think we'll probably want to define this outside of it. So inside of our sprite sheet editor here, let's create an onload method for this, and then that's when we'll either determine to load it from a file or just load it. We're not going to do the file portion until we do a part 2 of this, but from this one we will. We'll just simply not load a file. It's just a tool for us to click and poke around and get the index, or get the, not the index, but the column in the row. So we create an onload method here. So then within the onload method, we're going to want to also keep, okay, so maybe let's make this, yeah, let's make this public. Let's rename it to sprite sheet tile list. I just don't want to call it sprite sheet tile and have it conflict with the name. So this is a public property. So within here, we should be able to just we have to initialize a component, then on load. Yeah, so we know that the size of this, right? Let's take a look at the size, or pull up the sprite sheet. So there's 16 by 16, and these tiles are 16 by 16. So there's a lot of 16s. We could just have one global like 16 because it's 16 by 16 and the size is 16 by 16. But I think that if you're also following this along to implementing your own, it'd probably be a good idea to have these in separate variables. So let's do that. So it's a little more intuitive. So int column 16, private int rows 16, and we can make these constants. Then in here, we're going to loop through each column and then each row. So here, determine load by file else. So we're only going to focus on this else. To part 2, we will load this from a file. But for now, we'll just do it this way. So we're going to do for int y equals 0, y that's less than columns, y plus plus, for int x for our rows equals 0, x is less than rows, x plus plus. So now we can reference the sprite sheet renderer. I thought we renamed it. Whatever. Dot sprite sheet tile list dot add a new. Well, actually, we want to store a variable of it separately, I believe. You know, maybe we don't need to. Let's not. But we should probably add a constructor to this. At least for row and column, not name. We will make separate constructors for these based on whether it's loaded from a file or if it's not, or if it's just being hot loaded right at that point in time. But let's do that. So we'll do sprite sheet renderer dot sprite sheet tile list dot add. We want our x underscore y, and then we'll add a new sprite sheet tile sheet. Wait, why do I need to have shared? I'm just using. Yeah, I shouldn't need to specify that. Okay, that's good. And we'll pass in the column, which would be y, and then the row, which would be x, right? Yeah. Okay. So we add that, and then once it's finished determining this, we need to have a method that we can pass this date. Actually, we don't need to because we're just adding it. And then now we can populate our list box on the side. So we do private void populate list box. And then in here we can do lst box dot sprite sheet tiles dot data source equals new binding source. And then we will use the sprite sheet renderers sprite sheet tile list. Data member value can be null, and we need to do lst sprite sheet dot display member. So this is going to be the display value that shows up in there, and that's just going to be the key. So the IDX are indexed. And lst box dot value member equals just the value, because under the hood for dictionary, the key and value are just stored literally just as that. So now when we run this, if we did everything right. We did not, or I didn't. Oh, okay. Yeah. So now, if this is right, it did not. Oh yeah, I suppose it would help if I actually called this method. All right, yeah. So now we have 0, 1, 0. Is that right? 0. Seems like it should stay at 0 and then go 1. Yeah, I don't think that's. Did I? Oh, y and x. Duh. See, that always throws me off. Because y is the column, and jeez, what a mess! I should have just called these something else. I have to rename them after that, or make you I. Or we're gonna make you j. So we want our x followed by the y, which is j, and then we want here the column is I in this instance, and the row is j. So let's see if that's correct now. Yep, so we have 0, 1, 0, 0, 0, 1, 0, 2, 0, 3, and then we go, and when we do come back and make this a little better, we're going to break it up so that there's, a section, and then there's going to be a row. So you pick which row, and then you just have the column. So it's kind of like a nested folder-like structure. So now that we have that, as you can see, if you click this, we get an error now, which is expected, because believe it's null. So now that we're setting the data correctly, we need to. It probably doesn't help that I did that. So let's do this. So if sender is sprite sheet tile. Selected tile be equal to So sprite, we gotta cast it, sprite sheet tile, sender. Nope, then we just need the sender, so selected index, IDX, I call it IDX, equals $. We need the column, so selected tile dot column underscore selected tile dot row. And then we need to check to make sure that inside the list box we're going to find a value that matches this. So that's a pretty simple thing to do. We do int index equals lst box tiles dot what was it? Find string exact. There we go. Selected selected index. Yes, so that's the value that we're going to be searching for in there. And if it returns 1, it shouldn't, as long as it's not equal to -1. So index isn't equal to -1. That means we found a valid one. So we can just do lstbox sprite dot set selected, and we just pass in the index. And what's this value for Boolean? Selects or clears the selection. Yeah, that's fine. And then we need to have a way to know that it selected the right one, which we can do in our sprite sheet renderer here. We'll actually pass in the values that are being returned from here. Where am I doing this at? Yeah, I suppose it doesn't. We actually have to, handle what we're doing here, so that makes sense. So within our update method, we're going to have to do a little bit of matrix transforms, because before zooming in, everything is fine, but once you zoom in and change the mouse around, it's suddenly not fine. So this all stays the same. This all stays the same. So if it's being pressed, we need to look up that tile. So let's do this. We need to transform the mouse, so we'll call it var mouse transform equals vector. Yeah, we need to get vector2, so vector2 dot transform, and then we need to pass in new vector2, its position, so we need the mouse's relative position, so editor dot get relative mouse position dot x, editor dot y. Okay, now that we have that created, we need to invert the matrix, so matrix dot invert, and then pass in the view matrix for the camera, and thankfully it just comes with a method right here to get that, and it's like editor dot cam dot transform. Perfect. So now this should actually get us the proper position based relative to what we are zoomed in at. So now we can do the column portion here. So var column be equal to, we got to convert this to an integer. So int math dot ceiling, and then pass in the mouse transform divided by tile size, I think. So yeah, it would be mouse transform dot x divided by tile size, and -1 to factor in that it starts at a negative, like it starts at 0, right? So we're just going to take it -1, so it accommodates for that. So we can select the maximum and the min, technically, so this allows us to select the maximum. Otherwise, it would still just be wrong. So we have var row equals, we'll have our int math dot ceiling mouse transform dot y divided by tile size -1. So now we want to take a look at our sprite sheet tiles list here, and then we're going to do a try get value on it. So try get value, because we want to make sure whenever we actually do select something, if you clicked outside of the bounds of it, you wouldn't be able to actually get anything. So this is a safe way to do that lookup. Then that becomes column underscore row, and then we need an out var tile, and then if tile isn't equal to null. There we go. Then in here is when we would only invoke that method. And we need to pass in the tile. So this way, when the object sender knows that it's a tile that's being sent through the event, and then we should be mostly good to go. So we'll say the selector. Yeah, we actually need to store a value because we need to store that value so we know where to actually draw this thing. And remember that it's a rectangle that we're drawing. So we're going to switch this up after our point here, and we'll do private rectangle underscore selector new rectangle passing 0, 0, tile size, tile size. So now we have to set the selector rectangle to what was clicked. So then that becomes new rectangle, column times tile size, row times tile size, then tile size, tile size. Okay. So now when we're getting it, we have the selector right. And then we need to be able to actually get this tile. Yeah, so we can just do this to simply get the tile to raise that event, and then that becomes the sender. And then now, when we draw the rectangle, we will simply just pass in the position based on what we determined when it was clicked. This may work. Okay, yeah, so you see that, and also it changes and sets the selected one over here. So now, if we want to know what's capital Z, click that, boom. Okay, it's column 10, row 5. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Row 5, 0, 1, 2, 3, 4, 5, boom. And then that will be kind of a way for us to just know what they are and what we can do just for something extra to do in here, because it's something we're gonna have to do anyway. I always thought this was kind of cool. There's a thing called a property grid. So if we go down to here, there's a property grid. Where are you at? Oh, property grid, property grid, property grid. For real? I'm gonna search for it. Property grid, there you are. So it kind of, like this down here is technically a property grid right here. We can add that to this as well. Because eventually when we start giving these names, that'll be nice to have. So then let's give this a good name. So we'll call it pgrid pgrid selected tile. And then inside our method here, when it's clicked, we will do pgrid dot selected item. I think selected grid item equals selected tile. Oh, what is it again? Selected tile. How does it do that? Oh, I think it's just selected object. Selected object. Okay, there we go. So now when we do this and we click it, yeah, there we go. And we can add a collection here. I think it'll break, but in any event, then we can add like a series of metadata that will just become pipe delimited, and we can parse them out however we want. Eventually we'll be able to give it a name. Right now it'll technically retain its state, so I can say, like, you know, here his name, this is Dwarf 1. These will have to be marked as read-only because you can't change them. We can say this one is Dwarf 2. Dwarf 2. So now when I go back here and click it, it's Dwarf 1, Dwarf 2. I can give these, eventually I can give these names and export file, and then the game will read this, and then we have a clean way to say what is what. For the metadata, what I was thinking is maybe we want some functionality where we don't care what the symbol is, but we can just provide it like a tag to say, okay, because a cat is always going to be the capital C, but also a raccoon or something is also capital C. So within this metadata collection, you would add raccoon and all these things, and then we'll write code that loads out and says, okay, this is a raccoon is a thing. Now go out there and find it, and it'll look it up based on that. And then the name is just the description of exactly what it is. So this is Dwarf 1, Dwarf 2. Now this could also become, human, and it could still, represent the exact same thing. So, like I said, not the most exciting thing to work on, but now we do have a clean way to get this data pulled down, and now we don't have to go in and just consciously do our head. So for instance, if we wanted to do this capital R, we would know it's 2_5, and then we could add the rectangle, 2 and 5 here, and add it that way. Again, it could go one of two ways. It could be we are going to have a button or something that you click and it'll just give you the code for these rectangles that can just be passed in, or it'll be JSON file. I haven't decided which route we're going to go, but thank you for watching, and bye for now.